Good morning, welcome to Current Scrambled. In this class, let us see relationship between various thermodynamic parameters. Standard free energy change, standard enthalpy change, standard free energy change, how their values are obtained from EMF measurements, and we'll solve few problems. Okay, now let us see the relation between the thermodynamic parameters. From second law of thermodynamics, the standard free energy change delta G naught equal to minus NFE naught, where N is the number of electrons involved, F is called Faraday constant, 96,500 coulomb per mole, and E naught is the standard EMF of the cell. From second law of thermodynamics, again delta G equal to delta H minus T delta S, and for change in free energy with respect to temperature and pressure, that is temperature and pressure are varied, the change in free energy is given by this expression. Okay, so let us keep pressure constant. Okay, pressure constant, therefore there is dP equal to 0, there is no change in pressure, therefore S equal to dG minus dt. Okay, so let us take change in entropy, delta S equal to d delta G divided by dt, okay, minus sign, and let us substitute. Now delta G is equal to minus NFE. Let us substitute here, minus minus, it will be plus NF dou E by dou T at constant pressure. Okay, so let us rewrite this as delta H equal to delta G plus d delta S, because we can determine delta G naught from E naught. Now we need to calculate delta H. How it is calculated? Delta H naught equal to delta G naught plus d delta S naught. Let us substitute delta G naught value in this expression, plus NF. Okay, this is delta S, NF, and temperature T, dou E by dou T, constant pressure. This dou E by dou T is called temperature coefficient of the cell. This is nothing but how much EMF is changed per degree rise in temperature. For example, you change the temperature from 25 to 26 or 25 to 26, how much the EMF is changed. The rate of change of EMF with respect to temperature is called temperature coefficient of cell. Okay, let us solve a problem asked in GATE CSIR. The EMF of standard cadmium cell is 1.02 volt at 300 Kelvin. The temperature coefficient of the cell is minus 5.0 into 10 power minus 5 volt per Kelvin. In this case, the temperature increases, the EMF of the cell decreases because it is minus sign, and find the value of delta H naught of the cell in kilojoule per mole. Okay, so let us first write given data. What are all given? In this problem, EMF of the cell is E naught equal to 1.02 volt given, and temperature coefficient dou E by dou T equal to given. Okay, so the formula used is, in the previous slide we have seen, delta H naught equal to minus NFE naught plus NFT dou E by dou T at constant pressure. Let us substitute this. Okay, N equal to 2 because cadmium gives cadmium 2 plus 2 electron. There are 2 electrons involved in this process, into 90 Faraday constant 96,500, and the standard EMF of the cell plus 2 number of electrons involved, Faraday constant, and 300 Kelvin, the temperature is 300 Kelvin, into minus 5. So the answer delta H naught is joule per mole. To convert joule per mole to kilojoule per mole, let us divide this by 1000. Then you will get 199.755 in let us in 2 decimal places accuracy, 199.76 kilojoule per mole. This is the answer. Thank you for watching. Please share and subscribe. Thank you again.